Live. Complex numbers. Who knows what a complex number is? Ruben does. He was here yesterday. Yes, sir. You don't have to participate if you don't want to. He was on this though yesterday. He knew all this stuff already. Yeah, a complex number. They're always written in the form like this. They have a real part and an imaginary part. So we got to talk about imaginary numbers. They're really easy. I don't know if you did them last year or not.
Yeah, we did. They were hard to remember.
I did again.
Oh no, they're so easy.
Like one, I is -1.
I is not -1.
Oh, see?
I is the square root of -1. So what's, if I is the square root of -1, what's I squared?
1.
-1.
-1. Square root of -1 times the square root of -1. Right. You can take a nap if you want. Oh, you weren't here. That's right. It's like people that were here. It's gonna be real. It's gonna be the exact same thing. Yeah. You can catch a nap. I to the third power. What would that be? These are the really only two you need to like remember. Those are the only two you'll use in this class. But I'm pretty sure on Big Ben's placement test I've seen questions like find I to the 48th power. So it's really easy. Watch. What's I to the third? Negative square root of negative. Yep. It's I squared times I, right? That's how exponent, when you multiply, you have the exponents. So I to the third would be the same thing as I squared times I. So that would be -1 times the square root of -1, which is negative square root of -1. So then what would I to the fourth be?
Square root of
Nope. Isn't I to the fourth the same as I squared times I squared? Which is -1 times -1, which is 1. I to the fifth?
positive, square root of -1.
Yep, square root of -1. It's just I to the fourth times I, right? I to the sixth would be I to the fourth times I squared, so it would be -1. What's going to happen here? It's just going to keep repeating. Yeah, I to the seventh, I to the fourth times I to the third, so it's negative square root of -1. I to the eighth, I to the fourth times I to the fourth, which is 1. And it just keeps repeating. So really, it's just those four that repeat over and over and over and over. So going back to that question, like how would you find I to the 48th power? The way you do that is just figure out how many I to the fourths that is, and then see if there's any leftovers. What I mean by that is, if I do I to the fourth to the 12th power, isn't that the same as I to the 48th?
Yeah.
Because 4 to the 12th. Power to a power, you multiply them. So really you just divide that number by 4. Oh, it's 12. So that's, I to the 4th is 1. So this is the same as 1 to the 12th power. It's 1. So if you had I to the, pick a 2 or 3 digit number.
128.
148. How many times does 4 go into 148? I don't know. I'm going to calculate it though. So we just do 148 divided by 4. It's 37. So 4 times, that's just that. Guess what? It's 1 again. Take a 2 or 3 digit number that's odd.
147.
23.
4 to 5 to 3, so it's 1 times.
So that's I to the 4 to the, how many times is 4 going to 23?
It's
5.
5.
-1.
That would give you I to the 20th, right? So then you still need I to the 3rd.
Wait, time out.
Okay. This This is I to the 20th.
Oh, yeah.
Times I to the 3rd would be I to the 23rd.
So it's
So I'm just basically figuring out how many 1s there are. So this is just 1 times I to the 3rd. Well, I to the 3rd is the negative square root of negative 1. So there it is. See how you do that? Basically, you're just figuring out how many 1s there are, and then the leftovers is your answer. So if you had I to the 5,736, just divide that by 4. 57, 30, oh, I hope that's not divisible by 4. Don't be. It is. Dang it. Let's go 38. I to the 5,738. Divided by 4. Oh, it's 1434.5. So that's I to the 4th to the 1,434. 4 times 1434.
You're going way too fast.
Okay. I to the 4th to the 1434, I got that by dividing. I just take the whole number part. So then how many more what am I missing here?
I squared.
Yeah, I need an I squared. So I to the 4th to that, it's just 1
1.
So it's I squared.
times I squared. It's I squared, which is
Negative 1.
negative
Why
1.
do you do another I squared?
Because 4 times 1434 is only 5736. And I changed it to 5738. 4 didn't go into that evenly. That's what I want. I wanted one that didn't go into it evenly.
So when you do I to the 4th to the whatever, that's always going to be 1?
Yeah, because I to the 4th, any 1 to any power is just 1.
And then you have to times the because there's always going to be that whatever's left over.
Yeah, just the leftovers. If it goes into it evenly, if it's,
And that's what that
then
is.
it's 1. Like if it's a number that 4 goes into, your answer is 1. If 4 doesn't go into it, you'll either have two leftovers, 1 leftover, or 3 leftovers. So it's going to be one of those answers. Make sense? Not sure how important that really is, but maybe under no week. Oh wait. I was gonna say no week.
Our name is not on there.
Shh. Mr. Russ subscribes and they're watching.
I didn't even
They're not on your wheels. Anyway, imaginary numbers. Those are imaginaries. Well, so going back to complex numbers, we're going to do some work with complex numbers. An example of a complex number is like, I don't know, 2 plus 3i. That's a complex number. It's got to have a real part and an imaginary part. Well, we can do some operations with complex numbers. Like we can add them. So for addition, if we have 2 of them, so 2 plus 3i plus 3 minus I. If you want to add complex numbers, it's really easy. I bet you can guess what the answer is. 5.
5 plus 2i.
It is 5 plus 2i. It's that easy. It's just combining like terms, basically. It's just 2 plus 3. You don't even really need the parentheses. It's just there to separate them. 2 and 3 is 5. 3 and negative 1. 2. That's it. Want another one? How about 3 plus 2i plus negative 6 minus 4i plus 7. Try it. just add the real numbers, add the imaginaries. 3 minus 6 plus 7 is 4. And then 2 minus 4 is negative 2. That is all. We can do subtraction. So like 3 minus I minus 2 plus 3I. It's almost as easy as addition. You just subtract them instead of adding them. So you go 3 minus 2, 1. Negative y minus 3I, negative 4I. If you want, you could rewrite it. You could go 3 minus I, minus 2, minus 3I. You do that, right? Distribute the negative or subtract everything in the parentheses. And you go try this, 2 plus 3I, minus negative 1 minus 4I.
Three plus 7.
2 minus negative 1 is 3. 3 minus negative 4 is 7. Yeah. That is correct. What do you think's next?
Division.
Close. Multiplication first, and then we'll divide. Multiplication. It's just distributive property. So if you have 2 minus I times 4 plus 3I, you just do distributive property. So you got 2 times 4 is 8. 2 times 3I is 6I. Negative I times 4 is negative 4I. Negative I times 3I. Negative 3I squared. Well, now we got to combine like terms. This is 2I. You still got the 8 chilling there. But what's I squared? It's negative 1, isn't it?
Wait, negative 1 times negative 3?
So negative 1 times negative 3 is positive 3. So your final answer is 11 plus 2I. You should never have an I squared in your answer. It's always just A plus BI. It's not real plus an imaginary part. I squared is negative 1, so you just change it. Give me one more. Multiplication, 2 plus 4I. 2 minus 4I. Let's see if I'm right. See if she knows that. Did you get it already? You?
Me?
Yeah. No? Is this where you came in, Brendan? Oh, not yet.
Is it just 20?
It is just 20. That is the answer. So you got 2 times 2 is 4, minus 8I, plus 8I, and then minus 16I squared. Well, negative 8I plus 8I is 0. Negative 16I squared, just change the sign. I squared is negative 1, so it's plus 16. 4 plus 16 is 20. What's that called when we have the same thing like this and just the sign is different in the middle? What are those called? If you, when you factor it, a difference of 2 squared, if you had like, well, if that was x, or if you just had like 4 minus 16i squared and you factored it, yeah, it's a difference of 2 squares. You don't know what those are called? The person who I thought would get this is currently texting. So. You do! You know this. Dang it, I was wrong. Yesterday I was like, if Alondra was here, she would know this.
I don't think so.
But then Jeanette got it. She backed it up. Because you connected it to Spanish. Conjugate? Yeah. I thought that was, you didn't, wasn't that you that like got all excited when we did that earlier? No, Alondra, I thought that was.
I might have.
Remember when we used the conjugate? When we had like, you had like 2 over 1 plus square root of 3. And to simplify it, to divide, you had to do the conjugate. So you had to go 1 minus the square root of 3, 1 minus the square root of 3. Remember doing that? And then multiply across. Well, guess what? When you do division on imaginary numbers, that is exactly what you do. So if you have like 2 plus 3i divided by 4 minus 2i. It's just like simplifying square roots. You got to multiply by the conjugate of the denominator. No.
4 plus 2i.
Oh, I'm right here.
Where did she say? Do you want some?
If you got extra.
So,
4 plus 2i.
I didn't bring lunch today, so yeah. You multiply by 4 plus 2i over 4 plus 2i. So now you just multiply each one. What, Brenda? It's so funny. I feel like you're always talking crap about that. Now it's multiplication twice, so you gotta do distributive property. Know what I'm saying?
Yeah.
Do it. Can you do it twice? You just want me to move on. I'll just move on. You can try it in your homework. There's plenty to choose from.
Well, you're not going to do that one?
Yeah, I will, right here. So it's 8. On top, you go 8 plus 4i plus 12i plus 6i squared. Then on bottom, whenever you're multiplying conjugates, the I should go away. So 16 plus 8i minus, isn't this the one we just did? No, it's a little different. Minus 4i squared. Then simplify each one. So on top, let's see, that's 8 plus 16i minus 6. And on bottom we got 16, that's 0 plus 4. On top we have 24 plus 16i. On bottom we've got 20.
I got that way wrong.
How come?
I
I got that way wrong, actually.
2 plus 69 over 20?
2 plus 16i over 20 is correct. Yeah, 8 minus 6 is 2. I was excited about pancakes, I think. I'm still thinking about
Where'd you
that
get the
in the
24?
back of my mind. Where'd I get what?
24?
8 plus 16. Yeah, it's 8 minus 6 is 2, and then the 16i. Bottom at 20. But that's not, we're not
Can you
done.
divide them all by 2?
We have to divide them by 20.
Perfect.
2 divided by 20.
220.
2 20ths reduce. 1/10. And then 16 over 20. Reduce that. What goes into those? 4? 4 into 16, 4 times 4 into 25. So 4/5. So our final answer is 1/10 plus 4/5 I.
Why can't you just leave it at
How are complex numbers written?
You can't just leave it at 2 plus 69 over 20.
How
or
are
whatever.
complex numbers written?
I don't know.
They're written like
Oh.
a plus or minus. A real, you gotta have a number plus or minus another number I. So we have to write it like that. And the last thing. Square roots with negatives. So for example, the square root of negative 16. If I asked you yesterday, you would have said no solution or can't do it because you can't square root a negative. Today you can.
It's like a number and
Remember when we would break apart square roots? Like, so if you had the square root of 75, you would go, oh, that's 3 times 25. Alright? And oh, the square root of 25 is 5. The square root of 3, I'll just leave it in there, so it's 5 root 3. Radicals? Yeah, that's radical. Square roots are just the ones that are square. You could have third roots. That's the radical symbol. So when you do square root of negatives, all it is you go, oh, negative 16, isn't that the same as 16 times I squared? Because I squared is negative 1, right? You're here now. You know the square root of 16?
4.
You know the square root of I squared? I. Boom. You have 4I.
Is that a negative 2?
There?
No,
No,
it's
it's
not.
a dot on top of the I.
Oh yeah, that's my, what's that called? There's a name for that.
The dot on top of the I?
Yeah. I just heard the word the other day. Baseball players were talking about. I don't remember. Anyway, so basically what it comes down to when you do square roots of negatives, you just do it like it's a positive and throw an I at the end. Because it'll always just be times I squared, and when you do the square root of I squared, you get I. So like, the square root of negative 100 is 10I. Yeah, that easy. It's going to be 100 times I squared, 10I. What about the square root of negative 75? What do you think that is? Are you laughing because of how exactly the same it is as yesterday? Have a booger hanging out of my nose or something? Guys, you're taking too long to get square root of 75 is 5 root 3. Right?
So is it tittle? 5 root 3 1?
It's 5 root 3I. Yeah, there it is.
Is it a tittle on top of it?
Yes.
Does
I
I
don't
do
know.
one with square root, right?
I was gonna look it up too. I looked
The
it
I
up as
doesn't
soon
go
as
with
you
the
said
square
it.
root, right?
No. The I squared would be under the square root, so then you do the square root of I squared and I comes out. You just usually write it at the end. You don't write 5I root 3. You write 5 root 3I. I mean, this isn't wrong. It's still 5 times I times the square root of 3, but that's the proper way to write it. So where we're going to use that is when we do, like if I said, find the roots or the zeros of 3x squared minus 2x plus 5. If you had to find the zeros of that or the roots, what would you do? You'd factor it. I'll save you some time. It's not factorable. So then you would do quadratic formula, right? Can you tell me what it is?
Negative b plus or minus the square root of 4. Oh, b squared minus 4ac.
Over 2a.
Yes. So plug it in. So if I go negative b, what am I going to write here?
2.
Positive 2 plus or minus the square root of 4 minus 4 times 3 times 5 over 2 times 3. try it? Okay, I'll be quiet for a few minutes. I wouldn't do that though, because it's much longer. Simplify that one first. And then do the common denominator. I don't know if I want to be in the same number. Or you could do common denominator first. Checking it out.
You like chocolate chips?
Oh yes, I love chocolate chips.
So loud.
Does it hear me?
Tony's gonna watch this one.
Like, oh yes I do, oh yes I do.
They make pancakes in that class like every day, every week.
The easiest thing to make.
I could make pancakes right now.
No,
We
but like,
got a griddle, we
why
got
do they make
pancakes.
pancakes?
We still have
Is it
Larissa's.
not
Can we do it?
We just don't have syrup. So I'm gonna bring some syrup, we can make
Hey,
pancakes.
we have to.
Tomorrow?
I hate pancakes.
It's Friday.
Sure.
Awesome.
Alright, who's bringing what?
All you need is syrup.
This is not a party, we just need syrup. Because we're still gonna do math, lots of it, every day from here on out.
Wait, you have stuff to me.
Yeah. Got everything with syrup. Well,
My God, that's what
if you want butter, you gotta get butter. So you should have got 2 plus or minus square root of negative 56
Yes.
over 6. So then you gotta do the net square root of negative 56.
2 square root 14.
Which, yeah, it's just 2 times 28, 2 times 14, 2 times 7. Bring a 2 out. Can't do anything with that, so they stay in. It was negative, so it'll be I.
I got one.
Could have put I squared in there, but who cares? So you got 2 plus or minus 2 root 14 I over 6.